In the previous video, we mentioned that most of the ammonia and nitric acid production is used in the production of different types of fertilizers. In general, fertilizers are any substance that provide a primary nutrient to the plant, which includes nitrogen, phosphorus, or potassium. And the second category of substances used in agriculture includes the conditioners, which are substances that improve the physical or chemical properties of the soil. The nutrients of interest include major elements like carbon, oxygen, hydrogen that are typically provided through air, water, and primary nutrients including nitrogen, phosphorus, and potassium, and secondary nutrients including calcium, magnesium, and sulfur, and finally minor nutrients including a bunch of other elements that are mainly provided through soil. The purpose of fertilizers are mainly providing the primary nutrients and the secondary nutrients. The first and most commonly used type of fertilizer as a source of nitrogen is urea. And urea is industrially made by the reaction of ammonia with carbon dioxide at 14 bar and 180 degrees Celsius. This reaction takes place in two steps. The first step is the combination of ammonia with carbon dioxide to make the ammonium carbamate. And the second step is the decomposition of ammonium carbamate to urea and water. The first step is a quantitative step, and it's very fast at high pressures. Second step is an equilibrium step, and the conversion in that step increases with increasing temperature and increasing ammonia carbon dioxide ratio. However, it decreases with increasing the water carbon dioxide ratio. This is a flow chart describing the process, which starts by mixing ammonia with carbon dioxide into a reactor to make ammonium carbamate that can then pumped into a series of steps to decompose to ammonia and water. Some modifications can be done to the ammonia fertilizer to slow down the release of the fertilizer into the soil to make it last longer, and that includes the coating in of the product with polymers. The second fertilizer is ammonium nitrate, which is made by the reaction of nitric acid with gaseous ammonia. That neutralization reaction can be followed by a concentration step, either at 1 atmosphere and 105 degrees Celsius or 4 atmosphere and 178 degrees Celsius. That concentration step leads to a concentrate ammonium nitrate that pumps the concentration up to like 97 to 99%. Third step includes mixing with filling substances in order to reduce the nitrogen content from 35 to 33.5, and that is achieved by adding 4% by weight of powder limestone or dolomite or even kaolin. The final step includes prilling or granulation of the hot concentrated melt of ammonium nitrate to form it into droplets, which then fall down where they cool down and solidify as granules. This here is a flow chart that summarizes the process: evaporation of ammonia into ammonia vapor, then mixing with nitric acid in a neutralization reactor to produce ammonium nitrate. The second step involves flash evaporation to increase the concentration of the product that can then be mixed with the filler to decrease the nitrogen content in the product, and that filler could be limestone, dolomite, or kaolin. And the final step is either granulation or prilling of the product. Third type of fertilizer is ammonium phosphates, and that fertilizer is made by the neutralization of the pure phosphoric acid with ammonia. That direct neutralization reaction can only allow the formation of the monoammonium salt and the diammonium salt. The tri or polyammonium salts can only be obtained by reacting the phosphoric acid with urea. Ammonium phosphates are used generally as fertilizers, but they also can be used in fire protection as an additive to fire extinguishing agents because they are flame retardant. So they can be used for flame retarding purposes in different products. And that includes the prevention of afterglow in matches and the manufacture of flame retarding coatings. This flowchart summarizes the production of ammonium phosphate, mixing vapor ammonia with phosphoric acid into the neutralization reactor, followed by granulation and drying and processing of the product for production. Fourth major fertilizer in production is calcium phosphate, which can be produced by the reaction of calcium oxide with phosphoric acid with different ratios to produce the calcium dihydrogen phosphates or the calcium hydrogen phosphates. The superphosphates can be produced from the reaction of apatite with sulfuric acid to produce a mixture of calcium dihydrogen phosphate and calcium sulfate. And different types of calcium phosphates are used as fertilizers, and they are also used in the manufacture of baking powder, which is basically a mixture of calcium dihydrogen phosphate and ammonium bicarbonate that can mix in an acid-base reaction to produce carbon dioxide gas in the product. It's also used in toothpastes as additives that do not react with fluorides in fluoride-containing toothpastes. We're going to discuss the manufacture of superphosphates in a little bit more details. Superphosphates are major fertilizers as sources for phosphorus, calcium, and sulfur. And as we said, it's made by treating apatite with sulfuric acid to make the calcium dihydrogen phosphate and calcium sulfate mixtures. The sulfuric acid used in this step is 75% concentration sulfuric acid that is mixed with the phosphate rock for 30 to 60 minutes and then transferred to a reactor with very slow travel speed to allow for solidification and formation of the superphosphate. Fluoride byproducts can be sent to scrubbers and used to make sodium fluorosilicates. And the end product usually contains certain amounts of uncombined phosphoric acid, which makes the fertilizer hygroscopic. That's why neutralizing agents can be added to remove that free acid through the treatment with gaseous ammonia, which adds fractions of ammonium phosphate as a source of nitrogen into the fertilizer. This flowchart here summarizes the production process for superphosphates, which starts with the phosphate rock being crushed and then mixed with 75% concentrated sulfuric acid to produce a superphosphate product, and any fluoride byproducts in this step can be absorbed into scrubbers to make sodium fluorosilicates. A special version of the superphosphate is the triple superphosphate with the chemical formula of calcium dihydrogen phosphate, which is a water-soluble source of phosphorus that provides very high concentrations of phosphorus and calcium nutrients. This substance is produced by the reaction of calcium phosphate with phosphoric acid to produce the calcium dihydrogen phosphate and hydrofluoric acid byproducts that can be scrubbed to form sodium fluorosilicates, as we said. The last category of fertilizers include compound fertilizers, which are basically mixtures of different types of fertilizers ground together, granulated, and coated to slow down the release of the different nutrients. These compound fertilizers are made out of sources of different nutrients, potassium chloride and potassium sulfate as sources for potassium, superphosphates as sources for phosphorus, and other secondary nutrients and micronutrient and fillers. Mixing these raw materials with steam or water provides a sufficient liquid phase for granulation into different size of granules. It's also possible to achieve the granulation step chemically by reacting ammonia with phosphoric acid, sulfuric acid, or nitric acid. And in some cases, a concentrated solution of urea or ammonium nitrate can be also used for the granulation step. This is a flow chart that describes the production of compound fertilizers using the mixture of ammonia and phosphoric acid as a granulating medium, where the phosphoric acid is mixed with water, then mixed with ammonia to provide a granulated medium, and then the raw materials for the compound fertilizer are mixed into a granulating drum, and then the product granules are processed and packaged for production.